Welcome back to Summarize Science. What if a robot could be dropped into a completely new place and, without any prior training, learn to explore and navigate all on its own? That's the promise of a new system developed by researchers called AIMAPP, which stands for Active Inference Mapping and Planning. It's a biologically inspired framework that unifies mapping, locating itself, and making decisions into a single elegant model. So, how does it work? Instead of relying on perfectly detailed maps, which can be fragile, AIMAPP is inspired by how animals, including us, navigate. It uses a concept from neuroscience called active inference. Essentially, the robot is constantly making predictions about what it will see next, and then it acts to test those predictions. When what it sees doesn't match its prediction, surprise, it updates its internal map and understanding of the world. This internal map isn't a detailed blueprint, but more like a subway map, a network of connected places or nodes that it has visited. This topological approach is much more robust to errors and makes it easier for the robot to reason about where it's been and where it can go. It only creates a new stop on its map when it travels far enough from any known location, keeping the map sparse and efficient. To prove its capabilities, the researchers put AIMAPP to the test in a variety of challenging simulated and real-world environments. These included everything from houses and large warehouses to a 325-square-meter sandy parking lot. They compared its exploration performance against other state-of-the-art methods and even against a human teleoperating the robot. As you can see in these graphs, AIMAPP's performance was consistently high, exploring new areas with an efficiency that was nearly on par with human control. One of its biggest strengths is robustness. Traditional navigation systems can get hopelessly lost when their internal sense of position, or odometry, begins to drift from reality. AIMAPP handles this by constantly checking its sensory input against its map, allowing it to correct for drift and relocate itself. It can even adapt on the fly when the environment changes, like when an obstacle is moved, by updating the connections in its mental map. Beyond just exploring, AIMAPP is also incredibly effective at reaching specific goals. Researchers could give it a picture of a destination, and the robot would intelligently plan a path to get there. These paths were consistently near optimal, showing the system can balance exploring the unknown with efficiently exploiting what it has already learned. So, let's recap the key breakthroughs here. The AIMAPP system provides a way for robots to navigate completely unknown environments with zero prior training. It's inspired by brain function, using a connect-the-dots style map that makes it highly resilient to sensor errors and changes in the world. It performs on par with, and in some cases better than, existing complex systems, all while running efficiently on low-power hardware. This kind of technology could pave the way for more autonomous and adaptable robots in warehouses, factories, or even for search and rescue and planetary exploration. Thanks for watching Summarize Science.